Hello, good morning everyone. I hope the screen is visible.
Yes, ma'am.
Yes, ma'am.
Okay, so let's proceed. In the last class, we were discussing about canonical cover and third normal form. So we have gone through few examples of canonical cover, and then we had introduction to third normal form. So let's proceed now with the extension of the concept. So as we stated, the relations in second normal form have less redundancy than those in 1NF. But still, the relations in 2NF may suffer from update anomalies. Meaning, even though we have come up with second normal form of the relations, it is possible that we are having some redundancy still present in our relations. And that is the reason why we should go for one more higher normal form. So we have defined third normal form as a relation R on capital R is said to be in third normal form if and only if it is in 1NF and 2NF and no non-primary key attribute is transitively dependent on the primary key. So, what we did in 2NF, we considered the partial dependencies and full dependencies. So, 2NF was based on the concept of full and partial dependencies. As now, in third normal form, even though we remove partial dependencies and we come up with 2NF, it is possible that still there are certain transitive dependencies present in the relations. So, the second condition of third normal form says that if no non-primary key attribute is transitively dependent on the primary key, then we may say that it is in 3NF. And if it happens that few of the non-primary key attributes are transitively dependent on primary key, then we need to do something to make that relation in 3NF. Right? So, I hope you must have understood this definition. Further, we mentioned that we say that a database schema is in 3NF if all the relations in database schema are in 3NF. Meaning, our database schema usually is having many relations. Say for example, if we are considering our university schema, we are having lots of relations in the university schema. So when we are going to say that university schema is in 3NF, if each and every relation in university schema is in 3NF, then we say that university schema is in 3NF. Right? I hope you must have understood the concept. May I proceed?
Yes, ma'am.
Fine. So, with this definition of 3NF, now let us see our running example. So, we are having the relation client-rental relation in unnormalized form that we have seen. So, this is our original relation which is in unnormalized form. Right? What we mean by unnormalized form? There is no normal form exist in this relation. This is not even in 1NF. And the reason is few of the attributes are having set of values. Say for example, property number is having set of values. Right? So if we consider the intersection of every row and every column, we are finding more than one values in a single cell in the intersection. Say for example, if we consider this row and this column, then this is the intersection, this cell, right? So in this cell we are having more than one values, and that is why this relation is not in 1NF. So what needs to be done? We need to convert this relation in UNF to the relation in 1NF. So we have seen few approaches for this conversion. So if we apply the flattening of the relations, then we may come up with the relation in 1NF. We have seen this earlier. So now this client rental relation is in 1NF. So if we pick any row and any column, the intersection is having a single value, right? And this is true for any row and any column in this relation. So this is the relation in 1NF. But we found that whenever we converted the relation in 1NF, there are certain partial dependencies exist. Meaning, for this relation, we are having the primary key, client number, property number. So we are having the composite primary key for this relation that comprises of client number, property number, right? But if we look at the other functional dependencies for this relation, then we find few partial dependencies. And what are those partial dependencies? Yes, anybody can answer. We have gone through these contents before. So anybody who can answer, which are the partial dependencies in this relation?
Other one, client name is dependent on the client number.
Yes, client name is dependent on client number. Primary key is client number, property number. So client number, property number determines client name, but client name is partially dependent on the primary key, because client number can determine client name, right? So we may come up with this partial dependency, that is client number determining client name. So we are having here the dependency client number determines C name, which is a partial dependency. Is there any other partial dependency in this relation? Is there any other partial dependency in this relation?
Yes, ma'am.
Which is that?
Property address, rent, owner number, owner name is dependent on the property number.
Yes, very true. So, property number, the only attribute property number is determining property address, rent, owner number and owner name, right? So we are having one more partial dependency here, and that is property number determines property address, rent, owner number and owner name. So two partial dependencies we have found out. So by making use of these partial dependencies, we may decompose this relation in 1NF into 2NF. And the rule says that whichever are the partial dependencies, simply form one separate table for that partial dependency. So after removing the partial dependencies, what we may come up with is, for this partial dependency client number, client name will be having a separate table. For this property number determining property address, rent, owner number, owner name, we will be having the separate table denoted here as property owner, and whichever are the attributes, those remain. So what are the attributes remain? rent start, rent finish are remained. So along with my primary key, we put the remaining attributes in the table and we come up with one more table, that is rental. And this is now our 2NF decomposition. But now if we observe this decomposition in 2NF, what we find, if we look at this relation property owner, then what is the primary key for this property owner? The primary key is property number. So property number is determining property address, property number is determining rent, property number is determining owner number, and also property number is determining owner name. Right? But we are having one transitive dependency here. And what that transitive dependency is? Property number is determining owner number and owner number is determining owner name. I'll repeat. Property number, which is my primary key, is determining owner number, right? And owner number is determining owner name. So we are having the dependency like owner number determining owner name. And this is the transitive dependency in this relation. Do you agree with me? Yes.
Yes, ma'am.
So,
Yes.
as we have found out this transitive dependency, we say that this property owner is not in 3NF. Though this relation is in 2NF, it is not satisfying the condition for third normal form because there exists a transitive dependency in this relation. So this relation is not in 3NF. And what is the disadvantage that this relation is not in 3NF? Please see here. As there is this transitive dependency, owner number, owner name. Say for example, if I want to change the owner name for owner number CO93. What I want? I want to change the name of owner having the owner number CO93. If I am having more than one entries in this table for the same owner number, right, then everywhere I need to change this name if I want to change the name. And if I forget to change the name for one of the tuples, then I may have the inconsistent relation, inconsistent database, because there is update anomaly exists in this relation. And that is why what we need to do is we need to remove this transitive dependency from this relation. Now, how to remove the transitive dependency from the relation? Very simple rule. What we can do is we should decompose this relation further. Right? So property owner relation need to be decomposed. And how we are going to decompose the relation? We will be applying the same rule. Whatever is my transitive dependency, owner number determining owner name. For this transitive dependency, I'll be having the separate table. Right? So I'll be having a separate table owner with two attributes, owner number and owner name. Right? What else? Now, I have used these two attributes from my original relation in 2NF. Right? Now, whichever attributes are remained, these three attributes, and now this primary key of this new relation. What is the primary key of this relation? Owner number. Right? So, the remaining attributes along with this owner number will form one more table, one more relation. Right? So earlier 2NF relation is now decomposed such that we are having now these two relations in 3NF because we have removed the transitive dependency. And please see here now, if I want to change the name of the owner with this owner number CO93, I need to perform only one update in this table owner. Right? So even though this owner number is being used repeatedly in this property for rent table, I need not update name everywhere because we have removed that attribute from this table and we have come up with this separate table owner. So we have removed this update anomaly. Right? So if I want to modify the name, only once I need to modify it. Right? Are you getting me? Yes?
Yes, ma'am.
Any doubts so far?
Yes, ma'am.
Fine. So this is how we decomposed the relation in 2NF into the relations in 3NF. So now, given client rental relation in UNF, we go on decomposing the relation in higher and higher normal forms, and ultimately now we have arrived at 3NF. And whenever the original relation is being converted into 3NF, see here, we are having now 4 relations. Right? So out of one relation in UNF, now we have converted that relation into 4 different relations. So we have decomposed the relation in UNF in 4 different relations by applying the higher and higher normal forms. And now we are having this form of our database, which is in 3NF. And we have tried to avoid or to reduce the anomalies, the redundancies. Right? Now, what we are going to do next is, we are going to formally look at the algorithm for 3NF decomposition. Right? So practically, I have given you the tips how to convert the relation in 2NF into the relation in 3NF by making use of transitive dependency, right? But we are having a more formal algorithm for 3NF decomposition, right? So let us go through this algorithm. So what is the first step in this algorithm? Let FC be a canonical cover for F. What does this mean? Usually, we have been provided with the set of functional dependencies F. So, in 3NF, we require the set of dependencies FC. That means, in step number 1, we need to convert our set F into its canonical cover. So, we'll be using the canonical cover here, right? So let us assume that we have computed the canonical cover FC, right? What next? We are initializing one variable I equal to 0, right? And what we are going to do next is, whichever are the functional dependencies of the form alpha to beta in our canonical cover. For every dependency, we will be having one relation. See here what we have done. I is being incremented by 1. So originally it is 0. So I now becomes 1. Now I'll be picking up the first dependency in my canonical cover. So by making use of that dependency, I'll be coming up with my first relation in decomposition, R1. So R1 is given as alpha beta. What does this mean? We are combining the attributes from left hand side and right hand side of the dependency. And we come up with the relation R1. Similarly, if I am having say four dependencies in FC, then what I'll be doing is for every dependency in my FC, I'll be creating one table, one relation. Correct? Are you getting me? Yes? Is there any doubt so far? For each relation, for each functional dependency in canonical cover, we will be having one relation. Is that correct? Are you getting me?
No.
So may I proceed?
Yes, ma'am.
Fine. So we have formed separate relations now for individual dependencies in our FC. Okay. What next we are going to do? We are going to do next, or we are going to look at these relations, those we have formed in the earlier step. So if none of the relations is having the candidate key for R, if none of these relations is having candidate key for R, then we are going to form one more relation which includes the candidate key. So I is incremented by 1, right? And we'll be creating one more relation wherein we'll be having the candidate key for the relation. Right? So this is the optional step. When we are going to apply this, if candidate key is not included in any of the relations, I'll repeat, if candidate key is not included in any of the relations, then we will be forming one relation for candidate key. Okay. Now, once again, this part is also optional. So, what this part of algorithm is meant for? We are going to remove the redundant relations, if any. Right? So, what does this mean? Many times it happens that after undergoing the previous steps, we may have more than one relations having the same attributes. So if this is the case, then we are going to remove such redundant relations. So for that reason, we have written here few steps. Repeat, if any schema Rj is contained in another schema Rk. So meaning if one relation is part of another relation. Okay, then what we are going to do is we are going to delete this relation Rj. Right? So this is simply the process for deleting Rj. So simply what we are going to do is Rj is assigned Ri. Okay, and I is decremented by 1 because we are deleting one relation. Right? So obviously this subscript I will be decremented. Okay, so whichever are the redundant relations that we have formed by making use of earlier phases. If there are any redundant relations, we are going to remove the redundant relations if any. Right? So this is actually the formal process. Right? This is actually our formal process for decomposition in 3NF. Right? But many times we should use the tricks, those I have narrated earlier. And the trick is we need to find transitive dependency in the relation, and for that transitive dependency we may come up with one separate relation and the remaining attributes will go in another relation, right? And that is a simplified solution for 3NF decomposition. But to have the completeness, we should follow these steps in formally while decomposing a relation in 3NF. Okay? Now, let me go to one exercise. So let us solve one problem. We have been provided with one relation, and that relation is book. In relation book, we are having the attributes like title, author name, book type, list price, author affiliation, and publisher. So these are the attributes describing this relation book. We have been provided with the set of functional dependencies F. So we are having the dependency like book title determining publisher, book type determining list price, author name determining author affiliation. So this is the set of functional dependencies that we have. Now, the question is, what normal form is the relation in? And justify your answer. And apply possible normalization. So you will be having such kinds of problems in your exam. So given a relation, given set of functional dependencies, and you are asked to find out in which normal form the present relation in. And you need to specify the reason why you are saying that this relation in is in some normal form. So justify your answer, right? And further, you are asked to apply possible normalization for this relation. Okay, so I hope you must have understood this problem statement. Is there any doubt? Yes? Is there any doubt in the understanding of statement? Yes.
Yes, ma'am.
Have you understood the problem statement? Yes or no? Yes? Whether everybody has understood the problem statement?
Yes, ma'am.
Fine. Now, what would be the first step? If I want to solve this, what would be the first step? How to solve this problem? Yes. Please speak up. What we need to do first is, we need to identify the primary key for the relation. So, what would be the possible primary key for this relation book? Anybody?
Book title.
Book title. So you are saying that book title is the primary key. Why? Why book title is the primary key?
Because every book is having unique book title.
Now, see here, we have been provided with the set of functional dependencies, right? So, if you are saying that book title is the primary key for this relation, you need to justify that. And how we are going to justify? Simply, if book title is the primary key, then it should determine all the attributes in the relation. Do you agree with me?
Yes, ma'am.
Yes, ma'am.
So let us check whether book title determines all the attributes in this relation. Right? So if we want to do so, what we need to do is we need to find out the closure for this book title. Do you agree with me?
Yes, ma'am.
If we compute closure for this book title and if my result has all the attributes from the relation, then I may say that book title is my candidate super key, or that can be considered as my primary key. Right? So let us try to find out now closure for this book title. What is closure for book title? What is attribute closure for book title? We should refer to our set of functional dependencies. Correct? If I want to find out alpha plus, that is my attribute closure. We have seen one simple algorithm for that. What is the first step in the algorithm? My result is equal to book title. Correct? What next? I'll be picking up the functional dependencies one by one. So let us pick up the functional dependency book title determining publisher, comma book type. What I need to check whether left hand side of the functional dependency is present in our result. So it is present in our result. So what we need to do? We need to have a union of old result with the right hand side. Correct? So what we'll be getting here? Publisher and book type. Correct? Now let us go to the next functional dependency, book type determining list price. So whether book type is part of my result? Yes. So this right hand side also need to be concatenated to my result. So one more attribute gets added, list price. Okay. Now let us go to this third dependency, author name determines author affiliation. Whether author name is present in my result?
No.
No. So author name cannot be added in my result. Are you getting me?
Yes, ma'am.
So author name cannot be added in my result. Obviously, author name is determining author affiliation. So these two attributes are not present in my attribute closure book title. Do you agree with me?
Yes, ma'am.
Yes, ma'am.
So book title is not determining all the attributes in the relation. Right? So book title, only book title cannot be my primary key. Do you agree with me?
Yes, ma'am.
Fine.
Yes, ma'am.
So what we need to do is now just apply the common sense. Okay. So we have left with this author name determining author affiliation. So simply what we can do is this left hand side author name can be added now in this book title, and we may come up with a key like book title, comma, author name. So this would be our primary key. So whenever I am adding this author name in my primary key, obviously, what will happen? This functional dependency can also be considered while forming our result of closure of this. And this closure will now include all the attributes in my relation. And once again, we may say that only book title is not the super key because we have tested that earlier. Only author name cannot be my super key. So this combination of keys or this combination of attributes would be my super key or my primary key. Got it? Yes?
Yes, ma'am.
Fine. Now, we have found out our primary key for the relation, that is book title, author name. Okay? Now, this primary key determines unique values of all attributes. Unique values of all attributes. Meaning, if we assume one instance of this relation and if we try to find out the intersection of each row and each column, we will be having a single value. Right? So any of the attributes, if we consider in this relation book, that attribute comprises of a single value. Okay? And that is why we may say that this relation is in 1NF. Because there are no repeating group. So we are not assuming, in fact, this relation is in 1NF. Why? Because there are no repeating groups. And we have computed our primary key as book title, author name. Right? So this primary key determines the unique values of all attributes. Okay? And that is why we may say that this relation is in 1NF. But this is not enough. The relation is in 1NF. So let us try to find out whether there are any partial dependencies exist. Whether there are any partial dependencies exist. So, whether there are any partial dependencies?
Yes, ma'am.
What are those?
Book title determining publisher, book type.
Book title determining publisher, book type, yes, and also list price. Correct, na? Book title is determining book type is determining list price. So we may say book title determines list price. Right? So we may come up with two partial dependencies actually. Author name determining author affiliation. This is the partial dependency. Our primary key is book title, author name, but author affiliation is only dependent on author name. It is given. So this is one partial dependency. Other partial dependency is book title determining publisher, book type, and list price. Am I correct? Yes?
Yes, ma'am.
So, what we need to do? If I want to convert now, I have identified partial dependencies of this relation. Right? Now, what we need to do? If I want to convert it into 2NF, second normal form, what should I do? Yes. remove the partial dependencies. And I need to decompose this original book relation into several relations. Do you agree with me? Yes?
Yes, ma'am.
Now, let us follow our rule. What we need to do for this, let us assume this first partial dependency. One by one we need to do that. So, if we assume this first partial dependency, then what we can do is, for this partial dependency, we may come up with one table. So, book 1 is the table, is the relation wherein we are having attributes like author name, author affiliation. So, we are exploiting this partial dependency. So, we have come up with a relation book 1 wherein we are having two attributes, author name, author affiliation. Right? So, we are exploiting this partial dependency. So, we have used that. So, in other relation, we will be having remaining functional dependencies along with this author name. So, in the other relation, we'll be having remaining attributes and the primary key of this book 1. So, primary key of book 1 is author name. So, we are having that and all remaining attributes. So, book title, publisher, book type and list price. Okay. Now, what we find here is this book 2 is also not in 2NF because we have found out here this partial dependency already. Okay. So, this is not in 2NF and the partial dependency that we have is book title determining publisher, book type, list price. So, we are making use of this partial dependency now. Okay, and we are coming up with a new table, book 3, wherein we'll be using these attributes, book title, publisher, book type, list price. And in the other table, what we will be having? So out of this, I have used book title, I have used publisher, I have used book type and list price. So what is remained? Author name is remained. Correct? So what I need to do? I need to come up with one more relation wherein I will be having this author name, book title, primary key of book 3 and remaining attribute. Or in other words, we may say that in this there is no primary key available. So we should come up with one more relation having that primary key. So book 4 consists of book title and author name. Author name was remained along with this primary key book title of book 3. So we are having now this book 4 new relation with two attributes, book title and author name. Right? Is there any doubt so far? Yes. Is there any doubt? Please speak up. So what are the relations now in our 2NF after decomposition? We will be having in 2NF this book 1 book 3 and book 4. So this original relation book, which was in 1NF, is now decomposed into 3 relations, and we are having these 3 relations in our 2NF decomposition, and these relations are book 1, book 3 and book 4. Do you agree with me? Yes.
Yes, ma'am.
See why I am explaining everything in detail, because you need to solve such kinds of problems on your own, and you should understand how to think while solving such kinds of problems. So please understand. If you have any doubts, please let me know. These are very important problems. You may have such kinds of problems in your GATE exam as well, and you should be able to solve this. So unless and until you understand the concept, you will not be able to solve it. And I'm giving you the tricks how to decompose the relations. So please have a note. So I hope you must have understood now how the relation in 1NF is being decomposed in 2NF. So now our 2NF decomposition is having 3 separate relations, book 1, book 3 and book 4. Right? And we are having this set of functional dependencies with us. So let us try to find out now whether all those relations are in 3NF. Whether all those relations are in 3NF. So please try to find it out. We have undergone 3NF. Whether book 1 is in 3NF. Yes? Whether book 1 is in 3NF. What is the definition for
Yes,
3NF? It is in 3NF. What is the definition for 3NF? Yes, anybody? Definition for 3NF. Please pick up. What is the definition for 3NF?
The relation is in 3NF if it is in 1NF and 2NF, and no, there is no non-primary key attribute which is transitively dependent on primary key.
Correct. So if we look at this book 1, this relation, it is having only 2 attributes. One attribute, author name, is the primary key. So non-primary key attribute is author affiliation. Right? So this is the only non-primary key attribute. Correct? And that directly depends on the primary key. So there is no transitive dependency as such. So definitely this book 1 is in 3NF. What about this book 4?
It is also in 3NF.
This is also in 3NF because this relation comprises of my primary key itself for the entire relation book. Okay, and there is no issue of any transitive dependency. Right? So book 4 is in 3NF. What about book 3?
It is not in 3NF.
Book 3 is not in 3NF. This is not in 3NF. What is the reason?
Because list price is transitively dependent on book title.
Yes, very true. So see here, we are having the dependency book title determining publisher book type, and book type is determining list price. So list price is transitively dependent on book title because this dependency exists, book type, list price, right? So with the help of this transitive dependency, we are going to decompose now this relation book 3. So book 3 is being decomposed now such that in first relation, we will be having the attributes in our transitive dependency. So we are having book type, list price. Okay. So book 5 consists of these two attributes, book type and list price. So this will be our first relation in decomposition, book 5. So obviously book type is determining list price. So book type will be the primary key for this relation book 5. Now what to do? All remaining attributes. So we are trying to decompose which relation? We are trying to decompose this book 3. And we have used book type and list price for this decomposition, book 5. So what are the remaining attributes? Book title is remained, publisher is remained, and this primary key book type that we need to add. So book 6 comprises of book title, publisher, and book type. So this relation book 3 is decomposed in 3NF such that in this decomposition we will be having these two relations book 5 and book 6. Right? So my final 3NF decomposition is this book 1, book 4, book 5 and book 6. So in 3NF decomposition, we are having 4 relations. Right? We began with a single relation book, which was in 1NF. We decomposed book so that we can come up with the relations in 2NF. Whenever we considered 2NF, we found that one of the relations is not in 3NF and having the transitive dependency. So what we tried to decompose that relation, and ultimately we have reached to the decomposition in 3NF. Fine. So if you have understood the concept, we are going to conclude the session. So we have covered till 3NF. In the next class, we are going to look at the general definition for third normal form. So we have seen one definition for third normal form. We are going to look at one more general definition for third normal form. Right? And then we'll go for BCNF, that is the higher normal form than 3NF. So Boyce Codd normal form we are going to discuss in the next session. So once again, I would appeal all of you to practice such kinds of problems. In the next week, you will be having our ISC, wherein you will be having similar kinds of questions to solve. So you should practice, right? Fine. So let's conclude. Thank you.